Maintaining Homeostasis Through Electrolyte Balance by Marin Mills, Biology 1107K, Section 3, Dr. Irwin. Maintaining homeostasis is one of the major goals of the human body. Any shift or change within the body's internal environment signals various mechanisms to respond in order to return to a steady state. The mechanism we will focus on in this presentation is how the body regulates electrolyte levels. Let's start with some information on electrolytes and what they do. Early chemists such as Svante Arrhenius were some of the first to research and observe the nature of electrolytes. In the early 1900s, Arrhenius and his colleagues found that electrolytes were compounds that ionize when dissolved in suitable solvents, such as water. They are particles that can carry a charge and are present in your blood, plasma, urine, and other bodily fluids. The main electrolytes that can be found in the fluids of their body are sodium, chloride, magnesium, calcium, and potassium. Some of the major functions of these particular electrolytes include regulation of fluid balance, transportation of nutrients, support of muscle and mental function, and regulation of pH levels, just to name a few. Regulation of fluid and solute concentration across membranes is the most important role of electrolytes within the body. Without adequate levels of electrolytes, the water electrolyte equilibrium will be out of balance, resulting in impaired function of the body's processes. Fluid balance can have a profound effect on the major functions of electrolytes. Delving deeper into this matter will help us further understand how electrolytes are influential in maintaining homeostasis. At the cellular level, electrolyte content is regulated through the diffusion of the cell membrane, facilitated diffusion by way of protein channels, or active transport via protein channel pumps. The main protein channel pump our body's cells utilize is the sodium-potassium pump. It helps maintain a constant cellular charge through electrolyte balance within and outside of the cell. By pumping 3 sodium ions into the cell while pumping 2 potassium ions out, the cell is able to achieve this. The unbalanced charge transfer contributes to the separation of charge across the cell membrane. The sodium-potassium pump is an important contributor to the action potential produced by nerve cells. This action potential enables a nerve impulse to travel down a network of neurons until it reaches muscle tissue. Once there, the innervation of the nerve cell into muscle will eventually allow contraction of the muscle to occur. The importance of electrolyte balance can be traced back to the sodium-potassium pump. Inefficient concentration of sodium and potassium ions in both the inner and outer environment of the cell can stunt the transmission of the nerve impulse along the way. An imbalance can cause the action potential to be too low to send an impulse. As a result, the target tissue, muscle cells, do not become stimulated and no contraction will occur. This can be very detrimental if a desired muscle is needed for a particular body movement. These mechanisms alone are not the only factors at work at the cellular level. Inter- and extracellular levels of fluid must be ideal, or else this can result in imbalanced levels of electrolytes. Red blood cells are a prime example of cells that utilize fluid dynamics to achieve optimal conditions. Our body's red blood cells function best in an isotonic environment. That is, equal concentrations of solute, electrolytes, are found on either side of the cell. Due to water's tendency to flow in the direction towards high electrolyte concentration, the cell can shift from either a hypertonic or hypotonic situation. A higher concentration outside of the cell can cause the cell to shrivel up as water exits the cell. A higher concentration inside of the cell can cause the cell to swell up as water enters the cell. Cells in these conditions have impaired function and risk death. But how are electrolytes lost from our bodies? Electrolytes can be lost through the liquids excreted from the body. Excretion mechanisms such as sweating, urinating, and vomiting result in excess fluid loss. As fluid is lost to the external environment, electrolytes, mainly sodium and potassium, are lost as well. A resulting fluid and electrolyte imbalance will occur. Common symptoms of electrolyte imbalance include fatigue, muscle cramps, nausea, and dizziness, among various others. If severely dehydrated as a result of excess fluid loss, more serious complications can arise. Extreme loss of electrolytes can lead to coma, seizures, abnormal heart palpitations, and severe vertigo. In these situations, emergency medical help may be required. If not treated immediately, it can lead to loss of consciousness and may become fatal. Taking necessary steps before these problems arise helps reduce the risk of incurring an electrolyte imbalance. Proper nutrition is a vital step in combating the issue. Having an electrolyte reserve can serve as a protective measure if ever excessive electrolyte depletion were to occur. A diet that supplies the major electrolytes discussed earlier will help the body maintain higher electrolyte concentration prior to heavy loss. Foods that are good sources of sodium and chloride include various beef and pork products, cheese, and common table salt. Leafy green vegetables and a variety of fruits, especially bananas, are great sources for both potassium and magnesium. To adequately supply calcium needs, dairy products are the great way to go. Lactose intolerant individuals can look for products such as fortified orange juice for their calcium requirements. A balanced diet that will supply recommended amounts of each electrolyte will help ensure the body will function at optimum levels. Too much or too little can have adverse effects on the body's metabolic activity. Replenishing electrolytes after they have been depleted is a very crucial matter as well. During and after both illness and extended physical activity, the intake of electrolytes is very important. Both situations cause our bodies to lose electrolytes at a rapid rate. Liquid rehydration has been found to be the best method to refuel electrolyte levels. Beverages such as Gatorade provide an easy and effective way to accomplish this task. Our bodies are able to utilize and process liquid substances rather than solid foods because they do not require extensive breakdown to extract the necessary nutrients. Comparing sports drinks to water allows us to see why they are a better option. Although water is great for rehydration, it fails to replenish electrolyte stores. Electrolyte-containing liquids allow for both rehydration and reuptake of these vital compounds. In recent years, many manufacturers have developed products whose purpose is to replenish electrolyte levels. Many endurance athletes, such as marathon runners, cyclists, and triathletes, utilize these supplements for both training and competition. Whether it be powders, gel packs, or gel blocks, these substances provide a fast way to replenish electrolytes during activity. All athletes of any sport or skill level can benefit from these products, but proper regulation of intake is necessary to ensure these are not being overused. Electrolyte imbalances are no laughing matter. The consequences of letting your body get out of equilibrium can be devastating to your health and your well-being. Due to your body's desire to maintain homeostasis, it is essential to monitor electrolyte levels. In the future, this information will reduce the amount of injuries and complications that may occur. Looking at this matter in great detail equips us with the proper knowledge of how to recognize